welcome back to the shed. Now the time has come for my plasma table to actually get put to use and actually cut some metal, because despite me owning it for an embarrassingly long amount of time, it has never actually cut anything. Now I put loads of effort into putting it together, getting it set up, making the booth, doing extraction. I put the worktop in, I got the computer, new compressor, everything. It's all sat there ready to go, and for one reason or another I've just never got around to using it. But that is about to change. As you can see, it's become a complete dumping ground, which is what I promised myself I wouldn't do, and I went straight ahead and did. So first things first, get all that cleared, get the bench cleared, and then it'll be a much nicer place to work, and then I'll feel much better about coming down here to do some work, and I'll have space to do things. Now in round figures, this table and the associated bits to go with it cost me £7,000, and they've been sat here for nearly 4 years now, which makes me feel absolutely terrible, because my original intention of spending that money, I have not got £7,000 to just fritter away on things that sit around and do nothing. So fundamentally, this is here to make money, and on top of that, my intention was that it contributes to some of my own projects on the side to improve those. But fundamentally, it's here to make money. So it needs to earn at least £7,000 back to pay for itself before we're into profit. The trouble I've had is knowing what to cut on the table and what to sell. So I was thinking I could go down the route of advertising plasma cutting services generically, so people approach me, I cut what they want on the table. But there's so much competition in that field that I think that any profit would be potentially minuscule, especially in the start, without big throughput on the table. So little one-off things here and there for people is just not going to pay anything. So my thinking is that to add value to whatever product it is I want to sell, is that they need to have a higher complexity, or target a specific market where there's likely to be a demand for a product that doesn't yet exist. So I'm going to dust off the old CAD skills, and really get down to try and think about what products I can design that can be, at least in part, made up of pieces that are cut out on this table, i.e. things that aren't simple and easily done by somebody else. So to get the ball rolling and to save a bit of time, I bought this STL file of a horse's head from Etsy, and it was about 25 quid, and the guy who's made it has even done how-to videos on how to assemble the thing and you know, make it come to life. And so that's what I'm going to do. I'm going to start with one of those, maybe go on to a second and a third. I chose those not because I'm a horse person, but because I know there are horse people everywhere and they like horsey themed things. And with Christmas coming up, maybe, I don't know, someone might treat themselves or buy it as a gift or whatever. But I think they have the potential to look like a quality item that somebody might pay decent money for. And as well as not using the plasma table yet, I haven't picked up the welder for about 2 years either. So this will be a really good way to brush up on the old skills and get me back in the zone. So with all that said, let's get rid of all that. I missed one! God, that feels better. Well, there she is in all her glory. So what we're looking at is a 4x4 size, so that's 4 feet by 4 feet square sheet that it will take. Xtreme Plasma Table. So Xtreme Plasma, a company fairly local to me over in Gloucester, and they're responsible for the table and all of the hardware on top. But the actual plasma cutting itself is done by an Artec 50 amp plasma cutter. So it's a special one that's capable of being CNC operated. So it obviously integrates into the machine. So when I bought the table, what I got with it was obviously the table itself, the cutter, what I've put in this cabinet here, which is the brains of the outfit, and a PC that basically runs the interface that I've set up, which is the cable running across the floor here, set up to a monitor on the wall there, and buried under all this rubbish is a keyboard and mouse and stuff. So that's the console for running that table. Some people use even I think it's an Xbox or a PlayStation controller wirelessly, so they can actually stand by the table and guide the cutting head round really precisely like that. So that may be something that happens in the future, but for now, that's as far as I've gone with this table, is to be able to motor it round, but I have to use the mouse and keyboard and whatnot. The brake disc will stay there because, believe it or not, that's you want a bit of weight, something like that, because if you're cutting thin sheet materials, they got a tendency to warp, so that just keeps them flat, and so you get the shape that you intended. So when I bought the table, what you actually get for your money is obviously the table itself and everything you see on the top there, including the arm. You get an air dryer there for the compressed air supply. I bought this cabinet separately. This is an old server cabinet, I think. But this is I forget what you call it, but it's basically the brains, everything that runs the CNC operation, and then a PC which runs the interface, which is how you actually control the table and where you do design work and whatnot. So you also get obviously a plasma cutter itself. So that's a 50 amp RTEC unit, which is which you can see on the front there. It says Plasma 50 CNC, so it's a special one, which can be controlled by a CNC machine as opposed to a normal manual operated plasma cutter. So I bought the compressor separately. That doesn't come with the table. I already had a compressor, but a much smaller one, so needed a big one like that to run it, because they're quite air hungry. And you get the monitor and a keyboard and whatnot. You do actually get a pedestal that everything stands on for a console, but I didn't like it. It took up a lot of space and stuff, so that went in the bin. But yeah, so that's basically what you get. So what I've done on top of that is obviously installed everything, so everything's powered. I put in a big power supply that actually involved digging a trench down the garden to run a new cable down to the shed that's big enough to run the table through that separate little consumer unit. So it's separate to the rest of my shed power. So if the table experiences a problem, it doesn't plunge everything else into darkness, and fundamentally won't kill my PC in there. So yeah, obviously I've run the air supply up over the top there and down to the cutter through the dryer. There's a bit of a leak on that, so that's something I need to fix, because I hate just paying to compress air to let it back out to the atmosphere. Obviously I've built this enclosure, so I picked up a few tips from other people online. So I bought these cheapo shower curtains from Amazon, so hopefully they'll do the trick. A little bit of finishing off to do here and there, but then yeah, the rest of it is just plywood. I got some criticism on the Facebook forum for saying, oh, you built this enclosure out of wood, it's going to burn down, and doom and gloom and whatnot. But actually I've used a plasma cutter, handheld plasma cutter, loads of times in the past, and a welder, and the heat is so localized. Yes, there's sparks flying everywhere, but actually you could hold a lighter on that, and it takes loads to get something to burn off like that. So, and I'm always going to be in here. It's not that I'm going to set it going and then go out somewhere, so I'm not worried about that at all. But if it is an issue, there's things that can be done, so I'm not worried. So the other major things I've done is to fit an extraction system, so that's an outlet fan, and behind there is an inlet fan to balance the pressures. Because obviously I've got a curtain at the front, so if I was just to extract, then it would just drag the curtain out the way. So hoping that doesn't happen. So I cut a hole in the side of the shed and put a little shutter on it like that, just so to stop animals getting in when it's not in use. So that's it's all a bit Heath Robinson at the moment, and sort of Mark 1 edition. But yeah, I don't want to commit too much in one direction and then realise I've done something wrong and have to change course. So I just wanted it to be able to work, and that's it, So I've got control of the extractor fans there, so nice and simple. Well, how much better does that look? That gives me some space to work, and I'm not fighting with mess all the time. So next thing is I think that's that one, fire up everything. If I can remember what switches went where. PC, CNC. That's THC is torch height controller. We won't need that just yet. That is literally what controls the height of the torch, and kind of, I don't know, does some other clever stuff. And we don't need the plasma cutter on yet, or the extractor yet. So I might have to go in here and actually, there we are. Oh, we got life. Ah, that looks good. So as I said, I've not used this table at all before. I've had a quick go on the PC, just a sort of look round at the various bits of software on here. to start getting familiar with them, but I never really took it that far. So that's the big thing that I've got to get to grips with now, is how to actually use the table, because as far as I'm aware, there's sort of 2 or 3 main pieces of software to go from a CAD design or a DXF file, which is a 2D profile file, and holding a physical part in your hand. You have to go through different ones. So so I've basically got to learn that entire process, and without boring you to death, I'll try and show that to you as best I can. So this is the main piece of software that's used to control the table. It's called Xtreme CNC. Yeah, so this basically shows you your X, Y, and Z coordinates. So that's in space where the actual cutting torch is, and I think when you've got a design loaded up, it'll show it in this screen here, and this will be the lines of code, the G code as it's known, that the machine is following to cut the tool path you want. And there's control in here for the torch height controller. So I'm not familiar with that at all yet, but that I think improves cut quality, and it controls the Z axis, so that the distance of the torch is away from the piece of material, depending on thickness and current setting and all sorts. So yeah, there's that. But with this program, you can actually motor the table around manually, or jog as it's known. So using the keyboard thing. So if I move them, you can see that it drives around and does its thing, which is actually really cool to actually see it working and moving and doing something. So the next thing I got to do is get my head around all this software, load up my DXF files for the horse's head that I said I bought from Etsy, and try and cut them out and make something that I can sell. Right, here we are in sheet cam. I changed my mind slightly, so that the first thing I'm going to attempt to cut out is not the parts for the horse's head, because actually if I put those together and end up selling them, then I don't get to keep the first thing I ever made. So what I actually decided to do is cut out a logo, a company logo for the company of some friends of mine. So I already created the DXF on just a free online DXF converter, and imported it onto this machine. So we go new part. Do you want to import a drawing? Yes. Sea Fury logo, there it is. I'm going to scale it down by so it comes in at a quarter of its actual size, something in the region of 300 mil wide. So that's the logo. So what I'm going to do is actually cut out, so this is lettering, so that's the letter C dot and then the word Fury. So I'm going to cut out these letters so they'll go all the way through the piece of material, and then just cut the outside out, so it's just one disc that the letters are cut out from. The first thing I have to do is add the different cuts to different layers. So they are kind of steps in the process that the plasma table will work through. So all of these letters are holes, so they'll go on a layer called holes, where the plasma cutter cuts inside of this line, and then where you want to cut the outline out, you want to cut on the outside of the line, so it has to be a different layer because it's a different approach. Come up to mode, edit contours, you hold control and pick all of the ones that you want on a given layer. So you see they go from yellow to white. Right click, move to layer. So at the moment there's only one layer called 0, so we're going to create a new layer called holes, and then we're going to do the same again, edit contours, just pick the very outside line, so you see that goes white, move to layer, new layer, outline. So the logo is meant to have a band around it, which is what these other two lines here, the yellow one and the inner red one there, and obviously you've got the copyright mark there, which we're not going to put in. So I'm not going to cut these other two lines, so they'll just remain on the 0 layer, and we'll leave that there and we won't do anything with it. So the next thing to do is come up to operation plasma cut. So this is where you assign a cutting method to each given layer. So we want to do the holes first, so we'll tell it we want to do an inside offset. So you see the little pitch down here shows, you know, the white being the hole, and the cutting head here is on the inside of the line. Material is 2 mil steel, so the closest to that on there is 1.9 mil, so I guess we'll just stay with that. So we want inside offset. The layer we want is holes, material thickness and plasma cutter settings there, and as far as I know at the moment I can leave all the rest of that as it is. We accept that and OK. So you see a little line appear in operations down here, so that is literally the steps of the program that we're creating to cut this out. and you'll see this turquoise line here. So this is actually showing the cutter path and direction. So the purple line is the position of the cutter. So it starts in this corner, will traverse up to cut the U out first. The little pink arrows on there are showing the cut direction, and you can just see it there. That little piece here is the lead in. So it never actually starts cutting on the line. It starts outside of the line and then leads in. So you can see it on all of them here. So it'll start here, start cutting, and then come around in this direction following the arrows and cut out like that. And then you can see obviously the purple lines where it's going between the letters. So that's fine. So we need to do it again now for the outline. So we want outside offset, outline, leave everything else as it is, and okay. And then you see the same thing there. So there's the lead in, and then it go around. Notice that it goes the opposite direction, because with plasma cutting, I think the way that the air exits the nozzle, it's turning as it comes out, which has an effect on cut quality either side of the line. It's better on one side than the other. So that's where you see it going clockwise on outside cuts and anti-clockwise on inside cuts. And then the last thing to do to get it ready is file run post processor. So that's what actually turns these instructions into language, CNC language that the machine can interpret, which is commonly referred to as G code. So that just wants me to give it a file name. We'll save that. There we are. Save. Okay, so that's what it's going to do. Inside offset at that spec for that thickness of the material. Outside offset. Done. So now we can come over to Mac 3, load G code. There we are. There's the picture of what it's going to cut here. I don't know why it started up over there, but oh wow, look at that. Huh. So that's showing the chronology of the cut, I think. So that's working down through the layers of where it's going to start, or up, sorry. Yeah, so it's going to come along the red line, cut this one, this one, this one, this one, this one, and finally finish with the outline there. So that's cool. And then over here are these are the lines of code created by the post processor. And for a part as simple as this, you can look at how many lines of code there are. That's all the positional references and speeds and whatnot of the cutter, the instructions basically on how to cut it. So the table's turned on at the moment. That is actually moving. So now I need to reference the machine to the piece of material. So obviously the cutter head there is in the 0, 0 position, but the piece of material isn't. So if I drive it up so that it's pretty much in the corner, and then 0 those, that it now knows that is the 0 position. So that's where to start, from this bottom left corner. I don't know what this is all about here, but that'll probably become apparent. There's actually a simulate function in SheetCam as well. So at the top here, you can actually get it to show, obviously this is the cutting head, and it'll show you the path that it'll take doing the cutting out. That's really just for sort of checking that, so it's going to do what you think it's going to do, and you're not going to run into other problems. So yeah, it's doing the lettering there, does the dot, then goes out and cuts the outside out. Perfect. Okay, so the last thing to look at, I think, before we actually cut something out is this piece, which is the torch height controller. And what this does is it adds a feedback loop into the control system for the table for torch height. So it monitors the voltage of the arc, or it controls the voltage of the arc, and it can trim it up or down to maintain the cut quality. There's various parameters. So this is where it's controlled from, and there's various parameters on here to do that I'm not yet completely familiar with, but I'm just going to watch some YouTube videos now, and then in a minute I'll be familiar with it. Well, I actually resorted to getting the manual out, a very unmanly thing to do, so I'm told, and I happened upon this page, and it said before doing anything else really, you ought to do a test cut like this. So it's 11 parallel lines, the middle one of which uses the recommended feed rate for the given material, and all the others go up in 5% increments and down in 5% increments. So you can hone in on feed rate that actually suits you rather than the recommended one from the manufacturer. So I'm gonna have a go at doing that now. So I'll come over to this corner of the material. So it will just cut out a little square there with these lines on, and we can inspect them and then feed that information back into the tools in SheetCam, that will contribute towards us hopefully getting better part qualities when we do cut something of something that we actually want. Yeah, I think we're just about ready. It's absolutely hammering down with rain outside at the moment. Great thunderstorm. It's always cozy being in here, because we get loads of noise on the roof. I'll have to go quiet in a minute because the extractor will have to go on and the compressor, so you won't be able to hear a word. There it is, my first ever piece of CNC plasma cutting. Let's give it a little inspect. Warped a fair bit at this end, so the centre line, the centre line there is the recommended cut for this thickness of material. That's 5% slower, 10, 15, 20, 25%, so it's not a surprise to see a big warp there, because A, you're near the edge of the material, and B, that's 25% slower than recommended, so it's putting more heat in. It's taking longer to do that cut. I don't know why there was a failure there to start cutting, but sure we'll be able to work that out. So if you turn it over, then to be fair, they all look pretty even with the slag or dross on the back, but yeah, it's probably a minimum there on the recommended settings, which again is no surprise. But yeah, that's cool. So that was all done with the torch height controller off. There's a bit, I don't know if this is normal. It hasn't done it on that one, which is 5% faster. In fact, that's probably the least warped one actually, so perhaps 5% faster is the best. Could be argued that, yeah. Cool, okay, well, that's given something to start with. I was looking at the torch height controller as it was cutting, because I read that somewhere that you need to cut with it turned off, look at the voltage there, what the actual voltage is, and then that's what you want to set your nominal voltage to for when you have the torch height controller turned on. But the trouble is this arc voltage was all over the place. I saw it between, I think, 106 volts and 126 volts, and the tolerance in there, as standard, it's set to a 2-volt tolerance, so I'm not quite sure what to make of that. So I think I'm gonna get on the forum, post my findings, and see if I can feed that back in to increase the chances of doing a decent cut when I then switch to the company logo that we looked at doing it earlier. Cut one of those out and then potentially move on to the horse's head, like I said I was going to do first, but I didn't. Just found a super useful tutorial on YouTube on how to set the torch height controller automatically. So you basically hold the knob in the middle and it comes up with this screen saying press button after pierce. So you start it cutting, and once it's pierced through the material and normalized, you then press that button and it'll log that voltage as the nominal. So I'm going to have a go at that now. So I've used the same test piece, these parallel lines. If I click, oh yeah, M1 optional stop, so that's on now. So between every cut it will stop, and I'll have to press start again. So that's good. It won't get away from us. I won't have to cut out the whole thing. I'm just going to cut some test lines. Right, I'm bored of this practicing. It's time to have a go at something proper. Well, there we go. After nearly 4 years, I've actually put my plasma cutter to work and cut something useful out of it. There's the company logo that I spoke about earlier. It's come out really nicely. There's a bit of dross on the back, which is, I think, to be expected. Might be able to minimize that or eliminate it perhaps with fine-tuning of the settings, but for now I'm really happy with that. That's come out really nicely. So it says Sea Fury, if any of you can't read that quite properly, and they make ribs, not the barbecued kind, but the rigid inflatable boat kind. Incidentally, if you're into boats in the sort of 4 to 6 meter range, there isn't a better one on the market in the UK, so check them out. But yeah, the cut quality of this improved when I realized that the plasma cutter itself was actually still set to 20 amps, which is what it was originally. So I was under the impression that being CNC controlled, that Mac 3 would use the settings for the sheet cam tool to change the current of the cutter, but it looks like you have to still do that manually unless there's something I'm missing. But I upped it to 30 amps anyway manually, and that seemed to help. Yeah, so I actually ended up going over this twice, which is where you can just see a little divot in the top there. That's where it started to cut the perimeter, and then I stopped it to go over the lettering again, just because the centers weren't dropping out, and that's when I upped the current and went over it all twice. So it's obviously just a little mismatch there from when it came back round. But yeah, no, I'm really chuffed with that. So so that's enough for this video, but stay tuned, because there will definitely be a lot more coming off this table, both sort of artistic kind of things, signage and things like that, things for the garden inevitably, but also some engineering stuff to contribute to some of my other projects that I've had planned for a long time but not yet put into action. But yeah, watch this space. Thanks for watching. See you again.